Most CIOs think once an OASYS agent is trained, you're forever tied to SoundHound's runtime.
Actually, OASYS ships a vendor-agnostic abstraction layer and exportable protobuf bundles that let you pull the agent out cleanly.
So we could redirect the same intent graph to AWS Bedrock or an open source stack without rewrites.
Exactly. Plus, exit tokens and dual-run governance give you a measurable, reversible migration path.
Welcome to another deep dive of the CRM Position podcast. Today, we are talking about what is basically the Roach Motel of enterprise architecture, right?
Yeah.
AI vendor lock-in.
Yeah, the ultimate trap.
Right. I mean, if you're designing AI infrastructure right now, there's this almost universally accepted assumption out there. You spend, millions of dollars getting your proprietary data, your tuned workflows, your decision logic into these agents. But the moment you try to leave,
The provider suddenly holds the keys to your entire operational nervous system.
exactly.
Right?
The assumption is just that getting your logic out means, well, tearing everything down to the studs.
Which is a terrifying prospect for any enterprise leader. I mean, you're essentially handing over your core IP to a platform, and without a way out, that whole AI-driven process optimization just becomes this hostage-taking exercise. But the documentation we're looking at today tells a fundamentally different story about SoundHound's OASYS platform.
Right. The brief is actually really surprising here.
It is. The controversial truth we need to establish right away is that mandating export-ready artifact standards for every single agent you build, it isn't just some peripheral governance nicety. It's practically the only realistic lever you have to prevent a vendor monopoly over your decision logic.
Yeah, because in a highly regulated multi-cloud world, you just can't afford to have your core commerce or customer service agents permanently bolted to a single vendor's server.
Absolutely not.
So our mission for you today is to deliver a masterclass on exactly how this agent abstraction layer functions under the hood in SoundHound OASYS. We're going to explore the hidden operational failure modes you need to watch out for and show you how to design lock-in resilient architectures, ones that actually give you a real executable exit strategy.
Okay, so let's unpack this. We really need to start by looking at the actual mechanics, specifically this agent abstraction layer, or the AAL.
Right.
What the AAL actually does is it sits between the logic you build and the engine that runs it. And that allows the core orchestration engine to emit OpenAPI-compatible service contracts, which is a massive architectural shift from the old black box models.
I want to pause on that phrase for a second. OpenAPI-compatible service contracts. We throw these terms around a lot in architecture meetings.
Constantly, yeah.
But if I'm an engineer looking at my screen, what does this actually mean for my intent graph? Like, how does that contract let me physically redirect an agent?
Well, think of the intent graph as the brain's neural pathways, right? It dictates that if a customer says X, the agent triggers workflow Y.
Sure.
Historically, that mapping was written in a proprietary language that only the vendor's engine understood. But by emitting an OpenAPI-compatible contract, the AAL translates those proprietary pathways into a universal standardized web protocol.
Oh, so it's like translating a highly specific local dialect into standard international business English.
Exactly. That's a great way to put it. Because of that translation, you can take that service contract and point it toward AWS Bedrock or Azure OpenAI, and the agent's logic just flows into that new runtime because both systems speak that exact same standardized OpenAPI language.
Okay, so the live redirection makes sense. You're routing the traffic to a new engine. But live redirection is only half the battle, right? I mean, if SoundHound goes down or you terminate the contract, you don't just need to redirect the live feed. You need the actual agent itself.
Right.
And this is where the brief gets into what they call the cold export.
Yeah, exactly. Live redirection assumes both systems are up and running. The truly transformative capability here is the cold export. OASYS can export full model state snapshots.
Wow, everything.
Everything. We are talking about the neural weights, the fine-tuned prompts, and the complete tool registry metadata, and it packages all of this up into self-describing protobuf bundles.
Let's ground that term, too, for a second, protobuf bundles. Is this essentially like compiling software into a portable Docker container, but for AI intents?
Yeah.
Or are we just talking about a giant ZVIP file of JSON?
No, the container analogy is perfect. Protocol buffers, or protobufs, are a highly compressed, serialized data format. Google originally developed it. It is definitely not a messy ZIP file of text.
Right, okay.
It's a hyper-efficient, language-neutral way to structure data. You're taking the exact functional state of the agent, how it thinks, what tools it has access to, and you're vacuum sealing it, basically, freezing it into this portable format.
So you can just spin it up anywhere.
Exactly. It allows you to spin up a standalone inference container that reproduces the exact OASYS agent behavior completely offline or in a different stack altogether.
Well, wait, how does an environment like AWS Bedrock know what to do with a SoundHound tool registry? I mean, isn't it like putting a Mac hard drive into a Windows PC? How does the new platform actually read the bundle?
That is the brilliance of the metadata inside the protobuf. Specifically, it's the provenance tags.
Oh, right, the brief mentions tags that look like source OASYS, generation 2026 Aero 3 Air 15, model voice day 3.
Yes, those provenance tags are basically the instruction manual for the new host environment. When Bedrock ingests the protobuf bundle, the tags tell its orchestration layer exactly where this logic came from, what version of the model generated it, and how the internal tools map to standard functions.
So it completely eliminates the need for your engineering team to manually reverse engineer how the agent was making decisions.
Exactly. The state, the origin, the translation map, it's all baked directly into the export.
I have to push back a little here, though.
Okay, go for it.
Because that all sounds amazing technically, right? The container analogy works. The protobufs provide the map. But what prevents the vendor like SoundHound, in this case, from simply changing their API quietly? Or, just holding back the latest version of that bundle when they realize you're preparing to migrate?
Ah, yes. Vendor lock-in by stealth.
Right. Technical portability doesn't mean anything if the vendor decides to play games with your access.
What's fascinating here is how this architecture anticipates exactly that behavior. And it counters it legally. This isn't just an engineering feature. It is backed by formal portability clauses.
Wait, really? Contractual clauses?
Yes. SoundHound is contractually obligated to provide version-locked artifact dumps and the corresponding migration SDKs within 30 days of any major platform upgrade.
30 days. So it's not some vague promise on a marketing page. It's a hard service level agreement.
Exactly.
I mean, it's one thing to have the code to leave. It's another thing to have the legal right to enforce it.
Yeah, they've essentially turned lock-in risk into an enforceable service-level objective. It gives you, the enterprise, a clear, undeniable right to exit. The vendor cannot quietly deprecate an API without simultaneously handing you the tools to migrate away from it.
That definitely shifts the power dynamic. But let's be real for a minute. Migrations are never flawless. If you're a practitioner listening to this, you know the theory rarely survives contact with production, even with perfect contracts and clean protobuf bundles.
Oh, absolutely. And if we connect this to the bigger picture, we absolutely have to look at the practical failure modes.
Right.
The brief actually outlines 3 specific real-world scenarios where relying on these mechanisms can go disastrously wrong if you aren't managing the operational details meticulously.
Let's walk through those logically.
Yeah.
Say you've got your legal rights secured and you initiate the cold export. The most immediate failure mode happens right at the data extraction phase, right? Incomplete exports.
Yeah.
Imagine you're the CTO of an automotive company. You're running a highly specialized voice-activated purchasing agent in your vehicles. You pull that cold export, but the partial artifact dump quietly omits some proprietary voice enhancement submodules, the ones SoundHound natively uses to filter out background noise.
The operational fallout of that omission is immediate. You take that exported protobuf, you spin it up in AWS Bedrock, and, well, it boots up successfully. But because those specific acoustic modules are missing, the external runtime completely fails to hit your audio quality benchmarks.
Right. Suddenly, your commerce agent can't understand a driver over highway road noise.
Precisely. And in a commercial setting, that instantly causes a service level breach. The transaction fails, the driver gets frustrated, and your massive migration project is just completely stalled because the exported artifact wasn't a true one-to-one representation of the production environment.
Okay, so let's say you somehow avoid that. You get the full, pristine export, audio modules and all. The next hurdle is the actual cutover moment, when you switch the data feed from the old platform to the new one.
Right, the scary part.
Yeah, and this brings us to the second failure mode, which is purely a security and identity access management nightmare. The brief mentions exit tokens. For anyone who isn't living in IAM every day, what exactly is an exit token?
An exit token is basically a digital VIP pass that self-destructs. Technically, it's a signed JSON Web Token, or JWT. It grants your new external orchestrator temporary authority to invoke OASYS APIs, specifically to extract live data during the cutover window.
And temporary is the crucial word there.
Exactly.
But the failure mode happens if there's a misconfiguration.
Yeah.
Say your security team accidentally whitelists an expired JWT, or Or they just forget to set the hard expiration.
Hmm.
The external orchestrator in Bedrock thinks it has taken over,
Mhm.
but the native OASYS platform is still authenticated and running.
Exactly. This is the classic split brain scenario. OSIS continues receiving live transaction data after you've supposedly cut over to the new stack, so now you have duplicate processing. Two identical systems are executing the same customer intents, charging the same credit cards, or dispatching the same inventory.
I mean, imagine trying to explain to your CFO why you charged a customer twice for the same order just because an exit token didn't automatically revoke. That is a massive financial reconciliation error.
It is catastrophic, which
Wow.
is why you never just flip the switch blindly. And that actually brings us right to the third failure mode, which deals with the overlap period.
Okay.
To prevent those blind cutovers, there's a feature called dual run governance mode. In this mode, your OASYS agents run simultaneously in the native platform and in a sandboxed open source runtime like LangChain.
It's like flying a commercial plane with a co-pilot, but your altimeters might be calibrated slightly differently, right?
Yeah.
You need to make sure both engines agree on the altitude before you hand over the controls.
That is a highly accurate way to frame it. You're running the exact same inputs through two different engines to detect divergence. And the specific failure case here involves how the tool registry is interpreted.
Okay, give me an example of that.
Let's say your sandboxed LangChain replica interprets a tool registry call just slightly differently than native OASYS does. For example, LangChain applies an incorrect currency conversion API, or it hits the API half a second later when the exchange rate has shifted.
So the underlying math of the transaction is fundamentally different between the two systems.
Yes. And here is why it's so insidious. It might only create a 3% pricing discrepancy, and maybe only on a specific subset of international transactions.
So you might not even notice it at first.
Exactly. That error might only surface after a full week of parallel operation. If you didn't have that configurable validation period running in dual run mode, you would have migrated straight into a production environment that was silently mispricing your products by 3% indefinitely.
Wow.
It proves exactly why a sandbox validation period is a non-negotiable step.
So if you are the practitioner listening to this right now, how do you actually operationalize all these safeguards? Like, who actually does what to prevent the duplicate billing or that 3% divergence? The brief actually provides a very concrete mitigation playbook based on a RACI framework. Who's responsible, accountable, consulted, and informed. Let's look at this chronologically. It has to start with defining the exit.
Right. Step one is define and contract, and it bridges the technical and the legal teams. Your AI platform architecture team is responsible for defining the actual agent abstraction layer specification. They map out what that OpenAPI contract needs to look like for your specific workflows.
Okay.
But simultaneously, corporate legal must be drafting and negotiating those portability clauses.
Because if corporate legal doesn't secure that 30-day version-locked artifact dump, the architecture team's specs are entirely useless.
Exactly.
And if SoundHound delays that migration SDK beyond the 30-day window, you could easily miss a regulatory compliance deadline, which effectively forces you to extend a lock-in period you are actively trying to escape.
Exactly. Architecture defines the technical exit, legal enforces your right to use it. Now, assuming legal does their job, the ball is entirely in engineering's court for step two, which is generate and tag. OASYS engineering, working closely with data governance, must actually generate and systematically validate those exportable artifact bundles.
And a massive part of that validation goes back to those provenance tags we discussed earlier. Right? The source, the generation, the model. How do they ensure the data they're exporting isn't corrupted or manipulated?
Well, this raises an important question about insider threats, or honestly, just simple operational negligence.
Yeah.
Let's say an engineer realizes a critical financial decision was generated by an older, deprecated OASYS model that wasn't approved for use. If they try to tamper with the provenance tags to hide that fact before the export, it undermines your entire auditability.
Oh, that's a huge problem.
Huge. If a regulator finds out you cannot definitively prove which model made a specific customer decision, it exposes the firm to massive legal liability. So engineering is held strictly accountable for validating that the tags are immutable and accurate.
Okay, so engineering builds a clean, untampered export. But we still have that duplicate processing nightmare looming. Who owns the actual cutover switch? Step 3 is secure the cutover window, and this is where identity and access management takes the wheel.
Yep. IAM is strictly accountable for issuing and, more importantly, automating the revocation of those exit tokens. The CISO needs absolute assurance that those JWTs will expire precisely when the migration concludes.
It has to be automated.
It has to be. If you rely on a human being to manually revoke an exit token at 2:00 a.m. on a Sunday, you are practically inviting that duplicate processing disaster.
Which just leaves the final validation. Step 4 is validate via metrics. We talked about running LangChain and OASYS side by side, but how do you actually measure that divergence in real time? I mean, you can't just stare at two logs side by side. What is the actual metric the team looks at?
This is where the AI Ops Center of Excellence takes over to manage the dual-run governance mode. They rely on an exit readiness metrics dashboard. They track artifact completeness like, are we missing the audio modules? They track latency deltas, is the new platform slower? And they track compliance deltas, do we have that 3% currency discrepancy?
That's highly quantitative.
Extremely. The AI Ops COE gathers all that quantified divergence data so the AI governance board can make a data-driven, board-level go-no-go decision. You aren't guessing if you're ready to exit based on vibes. You're looking at exact mathematical deltas.
Here's where it gets really interesting, because the second-order effects of this architecture change the entire landscape of an enterprise. It's not just about risk mitigation or surviving a migration. It fundamentally alters your financial planning and your team dynamics.
The financial shift alone is profound. Adopting this abstraction layer absolutely adds short-term capital expense. I mean, you're paying teams to build adapters, you're running dual environments, you're funding export validation. But the long-term operational costs plummet, because when you inevitably decide to switch cloud providers in 3 years, say moving from Azure to AWS, you completely avoid the massive, costly re-architecting phase. Your agents are already portable.
Think about what that means for hiring, too. If the architecture is vendor agnostic from day one, does this change who we recruit? Do we stop hunting for expensive, niche SoundHound specialists?
It radically widens your talent pool. Your engineering teams can specialize in portable agent design, OpenAPI standards, and generic protobuf architectures, rather than spending years learning deep proprietary OASYS internals.
That's a huge strategic advantage in a tight labor market.
Exactly. You reduce your dependence on platform-specific staff.
And we cannot ignore the regulatory impact. We mentioned the EU AI Act earlier. These immutable provenance tags attached to every single cold export. They enrich your compliance audit trails dramatically.
Oh, yeah. If an auditor from the EU demands to know exactly why an AI agent denied a specific customer's loan application 3 months ago, you don't have to shrug and say, well, the black box did it.
Right.
You can trace that exact decision back to a specific generation timestamp and the exact model version, regardless of whether that agent currently lives in SoundHound or if you've already moved it to AWS Bedrock. That level of traceability isn't just nice to have anymore. It's becoming legally mandatory.
It also creates a massive financial safety net for the enterprise budget. Because you now have a quantified, measurable migration path, you can actually calculate an exit reserve. The benchmark mentioned in the brief is roughly 5% of your total AI spend.
Yeah, that 5% is key.
Setting that specific amount aside gives the board of directors complete confidence in the AI program's return on investment. For the first time, the cost of escaping a vendor is a known fixed variable.
Exactly. You aren't held hostage by unknown, sprawling migration costs anymore. You have an exact budget mapped to an exact technical exit strategy.
Which brings us to what you need to do with this information right now. We always want to leave you with actionable steps. Based on this masterclass, there are 3 concrete actions you should take this week.
First, get your legal and procurement teams to scrutinize your existing or upcoming vendor contracts, specifically for portability clauses. Do not sign anything unless you have a hard 30-day SLA for version-locked artifact dumps and the accompanying migration SDKs.
Second, audit your existing AI agents. Have your engineering leads verify that provenance tags, the generation timestamps, the source platforms, the model versions are actively and immutably being attached to your data exports. If they aren't, your audit trail is basically broken before you even start.
Third, sit down with your finance team and calculate your exit reserve. Run the numbers using that benchmark of 5% of your total AI spend. Have that quantified exit strategy ready to present to the board before they even think to ask you about vendor lock-in risks.
It's all about being proactive.
Definitely. And I want to leave you with a final thought to reflect on as you look at your own architecture this week. If your primary AI vendor pulled their platform offline tomorrow, how many weeks would it take you to stand up your core enterprise agents in AWS Bedrock using only your exported protobufs?
It's a sobering question. Listen, if you need to understand how CRM and AI platforms actually work under the hood, Hear complex topics broken down without the hype, and stay ahead of real architectural shifts rather than just swallowing marketing narratives. Subscribe to the CRM Position podcast today. We do the reading so you have the playbook.